Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's SAT Premium Study Guide, Chapter 6H, Solving Equations and Inequalities, where I'm going to do the problems at the end of that subchapter of Barron's SAT Premium Study Guide. Question 1, page 533. If 4x plus 12 is 36, what's the value of x plus 3? So notice that we can divide 4x by 12 by 4 to get x plus 3. So we don't have to just solve for x and do all this other work. We just divide both sides by 4. We get x plus 3 equals 9. Boom, that's answer choice C. This can be quicker than solving for x. In this case, it's not that much quicker, but it's quicker with more complex problems. Anyway, you could solve for x because you could say, okay, 4x equals 24, and then x equals 6. Also know that 6 is there as a distractor. Wrong answer, choice B. Question 2, page 533. If 4x plus 13 equals 7 minus 2x, what is the value of x? So you just combine like terms. So you add 2x to each side and subtract 13 from each side. You get 6x is equal to negative 6, so x is equal to negative 1, choice B. If ax minus b equals c minus dx, and of course this is question 3 on page 533, so ax minus b is equal to c minus dx, what is the value of x in terms of a, b, c, and d? So first you want to combine like terms. So I would add dx to both sides, so you end up with ax plus dx is equal to c plus b. So just add b to both sides. So then this negative b cancels out, we get c plus b, ax plus dx. Now we're going to factor out x on the left side, so we end up with x times a plus d equals b plus c. So then we just divide everything by a plus d, so we end up with x is equal to b plus c over a plus d, which is choice A. Question 4, page 533. If 1/3 x plus 1/4 x plus 1/6 x is equal to 12, what is the value of x? Well, first you need to find a common denominator for the fractional coefficients. The lowest common denominator, which is found by factoring 3, 4, and 6, then using all the common factors we need, is 3 times 2 times 2, which is 12. So we multiply both sides by 12 to get 12 over 3 times x, 12 over 4 times x, and 12 over 6 times x equals 144. So then this just simplifies to 4x, 3x, and 2x. So 4x plus 3x plus 2x equals 144. 9x is equal to 144. 4 plus 3 plus 2 is 9. And then you can factor this. You can go, all right, 12 times 12 is 144. And then you can factor that even further to just 3 times 4 times 3 times 4. So then 3 times 3x, which is 9x, is equal to 3 times 3 times 4 times 4. If we divide by 3 and 3, then we just end up with x is equal to 4 times 4, which is equal to 16, which is choice B. This factoring is helpful if you can't use a calculator. It's not, if this were on the non-calculator section, or if... Hopefully not, but if your calculator breaks or you're out of batteries or things like that, you can do this if you can't use your calculator. It's also good if you just don't want to stop to take the time to use your calculator. If you can do this effectively, this actually can take less time than using your calculator. Question 5, page 533. If 17 minus 2 square root of x equals 14, what's the value of x? Well, first thing we do is just, as in most of the other problems, combine like terms. So 3 is equal to 2 root x. So then 3 halves is equal to square root of x. So we square both sides, so we're going to end up with 3 squared over 2 squared, so that's 9 over 4, which is equal to x, because the square root of x squared is just equal to x. That's choice A. Question 6, page 533. If 32 to the a plus b power is equal to 16 to the a plus 2b power, then then what is a equal to? And they don't put this in the problem in the book, but in case you don't know, in terms of b. You should notice it because all the answer choices are in terms of b, but in case you don't, here we go. So notice that 32 and 16 are both powers of 2. So 32 is 2 to the 5th, 16 is 2 to the 4th. Substituting in 2 to the 5th and 2 to the 4th, this becomes 2 to the 5 times a plus b, then 2 to the 4 times a plus 2b. So now we can just remove the base 2 because obviously these are the same, so they just cancel out. So we get 5 to the 5 times a plus b is equal to 4 times a plus 2b in parentheses. So now we distribute. So we have 5a plus 5b is equal to 4a plus 4 times 2b, which is 8b. So we combine like terms to solve for a, subtract 4a, so we get a on this side, subtract 5b, so we get a equals 3b, which is choice C. Question 7, page 533. If the average, that is the arithmetic mean, the reason they put this in SAT problems is average and arithmetic mean mean the same thing. Ha ha ha. No, they do that because they don't want people complaining that they were only taught the word average or they were only taught the word arithmetic mean, so that's not really fair. So they just put it both there. Of 3a and 4b is less than 50 and a is twice b, what is the largest integer value of a? Well, all right, so we figure out the average of two numbers just by adding them together and dividing by 2. That's all you do for any average, is you just add all the numbers together and then you divide by the number of numbers. So 3a plus 4b over 2 is less than 50 from the problem. And a is equal to 2b from the problem, or you could say that's given, means the same thing. So what we're going to do is we'll substitute 2a for 4b. Since a is equal to 2b, 2a is equal to 4b. So we're going to end up with 3a plus 2a over 2 is less than or equal to 50. Of course, we're going to multiply by 2 and combine like terms. So 3a plus 2a is 5a, and then you multiply by 2, so 5a is less than 100. So that means a has to be less than 20 when we divide both sides by 5. So the largest integer value is 19, which is choice C. Make sense? Question 8, page 533. 1 over a minus b equals 5, then a equals, again, something in terms of b, which you can tell by looking at the answer choices. First, you want to multiply both sides by a minus b. So now we have 1 is equal to 5 times a minus b. Now we're going to divide by 5, so we have 1/5 is equal to a minus b. So then a would have to be equal to 1/5 plus b, because we just add b to both sides, so we get a by itself. So a is equal to 1/5 plus b, which is choice C. Question 9, page 533. If x is equal to 3a plus 7 and y is equal to 9a squared, what is y in terms of x? Well, we see that x minus 7 equals 3a by manipulating the first equation. We also see that 3a in parentheses squared is equal to 9a squared from the rules of exponents. Therefore, y is equal to 3a squared, which is x minus 7 squared, which is choice A. It's a good idea to check the answer choices so you don't do extra work, such as actually multiplying out using FOIL to go x minus 7 times x minus 7, so you can end up with x squared minus 7x, outer, inner, minus another 7x, that becomes minus 14x. Negative 7 times negative 7 is 49. And then you're just going to feel silly that you did extra work when you could have just checked the answer choices and seen that you could have stopped once you got x minus 7 squared. So don't feel bad if you do it. I do things like that all the time, but it's good to take a quick look at the answer choices to see when you can stop. Okay. Question 10. Page 533. Which of the following is the solution of 3 times the absolute value of x plus 1 minus 5 equals negative 2? So the first thing we're going to do is add 5 to each side to get rid of that term. So we just end up with 3 times the absolute value of x plus 1 equals 3. Obviously, if we've got a 3 here and a 3 here, 3 on both sides, let's divide by 3 to get rid of that. So then we have the absolute value of x plus 1 is equal to 1. So the easiest way to solve an equation with an absolute value in it is to, no, this shouldn't be find, it's to find with a D, sorry about that, what value of x will give us the number on the other side, or the opposite, that is the additive inverse. So if one is a, the other would be negative a of the number on the other side. So we need a value of x that gives us either 1 or negative 1, since the absolute value of either 1 or negative 1 is 1. So our possible solutions are 0 and negative 2. So 0 here, because 0 would give us 1, absolute value of 1, which is 1. Negative 2 gives us negative 1, absolute value of negative 1 is also 1. 0 is not an answer choice, so negative 2, choice A, is our answer. Question 11, page 534. If 6x squared minus 7x plus 2 equals 0, what's one possible value of x? Let's try to factor this. Try 3x minus 2 times 2x minus 1, and then we're going to FOIL to see if we get the original trinomial. So 3x times 2x, that's 6x squared, and then the outer is minus 3x, the inner is minus 4x, because negative 2 times 2x, and the last is 2. So we get 6x squared minus 7x plus 2. Awesome, it works. Therefore, we need the values that make the equation equal to 0 where one of the two factors is 0. So 3x minus 2 equals 0 where x is equal to 2/3, and 2x minus 1 is equal to 0, where x equals 1/2, because 2 times 1/2 is 1, 1 minus 1 is 0. Just like this one, 3 times 2/3 is 2, minus 2 is 0. So you can grid in either 2/3 or 1/2, doesn't matter which one you do. Yeah, you could grid in the decimal if you want to, but why? Okay. Question 12, page 534. 7x plus 10 equals 44. Then what is the value of 7x minus 10? All right, the slow way to solve this, I think Princeton Review calls this the Joe Bloggs way. It's their hypothetical kind of imaginary student who, Joe's a good guy, does things the way that his math teacher taught him to, but that's not always the best way to do it on the SAT or ACT or whatever test you're taking. So this would be the Joe Bloggs way to go, all right, I want to solve for x, so then I'll multiply by 7 and subtract 10. So you could do that. You get 7x is equal to 34, so then it's 34 over 7, and then you multiply 34 over 7 to get 34, and then you subtract 10 and get 24. That's more complex, and it's also makes it more likely you're going to make a mistake than if you just automatically recognize, hey, wait a minute, this is 7x plus 10 and this is 7x minus 10. So all I have to do is subtract 20 to get to 7x minus 10. Boom, 44 minus 20 is 24. I don't even really have to think about it. If you're not quite that perceptive or you're just a little concerned, fine, subtract 10 and then you get 7x equals 34, and then subtract another 10 to get 7x minus 10, and you still get 24. So grid that in, you get 24. So as again, I said, if you see the 7x minus 10 right away, great, just subtract 20. If you didn't see that, just subtract 10 to get 7x, then subtract another 10 to get 7x minus 10. Let's move on. 13, page 534. If 3x minus 4 equals 9, what's the value of 3x minus 4 squared? Hopefully most of you can see, well, okay, all I have to do is square both sides, and I'll get 3x minus 4 squared, and on the other side I'll have 9 times 9, which is 81. Now, if you didn't see that, you could do it the slow Joe Bloggs way, which is 3x times 3x is 9x squared. And then the outer is minus 12x, the inner is minus 12x, and the outer is 16, so you end up with 9x squared minus 24x plus 16 equals 81. 9x squared minus 24x minus 65 is equal to 0. All right, I can already see I'm going to need to use the quadratic formula to solve this. That's going to be a big mess, especially if it's on the non-calculator section. I don't want to play with numbers like this, and I don't see a common factor I can easily divide by. So it's really easy to mess this up if you're having to do arithmetic you haven't really done since 4th or 5th grade, where you're doing multiplying large numbers or doing long division, etc. So don't do it this way. You can just do it in seconds by squaring both sides to get 3x minus 4 squared equals 81. Do that, grid in 81, get on with your life. Okay. 14, page 534. If x to the negative 3 is equal to 1 over 4x, what is one possible value of x? And in case you're wondering about all this, these italics, when I use the formula thing in PowerPoint that I do these on, if you write with normal letters where a formula goes, you get kind of this math font and it's italicized, but it does look very intense. What is one possible value of x? Please, pray tell me what is one possible value of x. Okay. Anyway, getting back to this. X to the negative 3 is 1 over x cubed is equal to 1 over 4x. All right, so we can just flip both of these, make them the reciprocal, so we end up with x cubed is equal to 4x, or 4x is equal to x cubed. So then we can divide through by x, so we get 4 equals x squared, so x is equal to 2 or negative 2. Now this is a grid-in question in this book, so since you can't grid in a negative number, just grid in 2 and enjoy your life. Okay. Question 15, page 534. If x squared minus 7x plus 12 times x squared minus 11x plus 24 equals 0, what is one possible value of x? Wow, this looks like a big, ugly, scary problem, doesn't it? Well, does it matter that they have two trinomials that you can probably should be able to see you can factor into or into two binomials, so four, monomials, whatever, so anyway, basically they just put together two pretty average factoring problems from algebra. So we need to find a value of x that will set this equal to 0. So then we know either this one, x squared minus 7x plus 12, or this one, x squared minus 11x plus 24, has to be equal to 0 because anything times 0 is equal to 0. So x squared minus 7x plus 12 equals 0, x squared minus 11x plus 24 equals 0. These are both pretty easy to factor. We just need to find, for this one, two numbers that add up to minus 7 and two numbers that multiply to 12. So the other way you could say in more professional mathematical language would be the sum of the two numbers is negative 7 and their product is 12. So negative 4 and negative 3 work because we can see, okay, well, negative 4 plus negative 3 is negative 7. Negative 4 times negative 3 is 12. So let's just write x minus 4 times x minus 3. That works just fine. We can use FOIL to get the original trinomial. Okay, x squared first, outer minus 3x, inner minus 4x, and then 4 times 3 is 12. So x squared minus 7x plus 12. And so it works. That's not a new word called soit. That's just me missing a space. Sorry about that. Didn't notice that mistake till just now. Anyway, using the same method, we see that x minus 8 times x minus 3 is a factorization of x squared minus 11x plus 24, because negative 8 minus 3 is negative 11, so the x factors work, or the x coefficients, and then negative 8 times negative 3 is 24. So we have, a negative 8 minus negative 3 is... negative 8 minus 3, not negative 8 minus negative 3. That would be negative 8 plus 3, which is not what we're talking about. Anyway, negative 8 minus 3 is negative 11. And negative 8 times negative 3 is 24. So the other ones you could try are 2 and negative 12, but those add up to negative 14. 4 and negative 6, those add up to negative 10. So those won't work even though they are both factors of 24. So then we go on to the next page. So we have x squared. Okay, we're just repeating the question here. So we know that x minus 4 times x minus 3 times x minus 8 times x minus 3 are all the factors because these are the factors of this one. So x squared minus 7x plus 12 is x minus 4 times x minus 3. X squared minus 11x minus 24 is x minus 8 times x minus 3. So any value of x that makes one of these factors equal to 0 works. So we can either use 4, 3, or 8. So since we have two x minus 3s, 3 is the answer to both of those. So we really only have 3 distinct answers. But that's okay. You only need to come up with one value. So you can grid in 3, you can grid in 4, you can grid in 8. It's your choice. Any one of those will work. And that takes us to the end. So for the best results, please, if you haven't already, go buy the Barron's SAT 30th or 29th, or even the 28th edition. This video does cover, in case you haven't figured it out, 532 through 533 in the 30th edition, or maybe it's 533 through 534. Whatever, sue me. Anyway, covers the questions at the end of the solving equations and inequalities. So get the 30th edition of Barron's SAT or the 29th. They're identical, basically, or close enough. There might be one or two problems that are changed. And even if you can get the 28th, which I believe is the one that's titled Barron's New SAT, that was released for the 2016 new SAT, when the current edition, or the current format, I should say, of the SAT debuted in 2016. So probably Barron's new SAT came out in late 2015, but you probably don't care. Anyway, 28th, 29th, 30th edition, any of those are great. Why you should get a copy of the book, you ask? Well, not everything in the book is in these questions, so it's actually good to look at the subchapters of Chapter 6 in this book and actually read it. And the older editions of this book, so the 28th or 29th editions, can be had cheaply, if not for free. You can go to used booksellers. You can talk to older kids who've already taken the test. You can go to public libraries. Public libraries in the San Francisco Bay Area often sell old test prep books and old any kind of books for literally a dime a piece. So, or you can borrow the current edition from the library. If you plan to use a library copy that they're lending and not selling to get rid of, I suggest you start early, or if you're going to go buy a new edition, again, start early. There's no worse feeling than needing a library book someone has checked out, or trying to buy a review book that's sold out, especially if it's 2 days before the test and you don't have time to order it or whatever. Or you could go look for an online edition of it. Anyway, you're going to need longer than a couple days to study for the SAT, so get yourself a copy of the book if you haven't already and start studying it. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. If you're worried about getting spammed, look, YouTube is run by Google. They don't run their business that way. They'll send you a few notifications, but they're not really that interested in bombarding you. Why do I care? Well, it's simple. YouTube will not let me share any ad revenue until I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time in the last year. Right now, I think my current subscriber count's 747, so still could use more subscribers. And for the same reasons, you're not only welcome but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. And I reserve the right to delete comments from and block those who specialize in destructive criticism, the opposite of constructive criticism. Trolls or people who like to post things that are off topic, people who are just spamming usually worthless products or just disturb people who want to vent in any forum they can. If you have a copyright issue, you think I've copied something that you own the rights to, or some other problem like that comes up, please contact me. If you have a problem with me, with these videos in general, contact me. If you have a problem with me, hell, contact me. Fine, maybe we can work it out. And so if you'd like to contact me, whether it's for a good reason or a bad reason, please call me at 415-623-4251. You can text my cell phone at 415-623-4251. And you can email me at john@johnlineball.com. My mailing address is 1859 Powell Street, number 109, San Francisco, California, 94133. Thank you very much for watching. And here's some more contact information. If you want to find me on Facebook, you can find this business, facebook.com/Lineball Tutoring, all one word. Instagram, you can find me on Instagram.com, John Lineball Tutoring. You can call me at 415-986-7355 if you'd like to call me on my home office number instead of my cell phone for some reason. And email, you can reach me at john@johnlineball.com. And my website is www.johnlineball.com. www.johnlineballtutoring.com also works. Take you to the same website. And I have a new locals.com site, so you can find me at testpreparation.locals.com. All right. That's it. Hope you have a good day, and good luck on the SAT.